This is a video presentation of the homework helper for Chapter 7, Section 7 in the 8th grade workbook entitled Transformations. So let's go ahead and take a look at the first set of questions there. The directions are the same for both. They're asking us to graph the translation. A translation is simply a fancy way of saying move the figure. Whatever they describe there, you're going to apply to each corner of the shape, and then after you apply it to each corner, each vertex of the shape, you're then going to connect the points created by the translation to create the new shape, or what is called the image, which is what you get after you do any transformation, in this case a translation. So in this A example here, the number 1 question rather, they're asking us to move the shape 3 units left and 9 down. So I'm going to move each corner 3 left and 9 down. So let's go ahead and start with the X. I'm going to move the X 3 left, 1, 2, 3, and then 9 down, 1, 2, 3, 4, 5, 6, 7, 8, 9. So there is my new point X. Now we'll take Y and do the same thing. I'm going to move it 3 jumps to the left, 1, 2, 3, and then 9 down for it as well. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I'm going to take point Z and do the same thing. Move it 3 jumps to the left, 1, 2, 3, and 9 units down. 1, 2, 3, 4, 5, 6, 7, 8, 9. And there is point Z. And again, what I need to do to finish here is connect now my new points. And there is my image post-translation. Let's continue now with questions 3 and 4, where they're asking us to graph the reflection. The reflection is exactly what you think it means. If you're thinking about a mirror, you're thinking about the right thing. It's a reflection about 3 locations, usually across the x-axis, across the y-axis, or it can be about the origin, which is usually a diagonal reflection. You can truthfully reflect a shape over anything you want. For instance, looking at question number 3 here, if I wanted to reflect it over the line x equals 1, this would be the line x equals 1, so I'd be mirror imaging it over that line. But as you can see, our directions here stick to the pretty plain and vanilla of reflecting across the x and the y-axis. Let's go ahead and take a look at 3, across the x-axis. So remember, the x-axis is the one that runs left to right. So the points aren't going to change here in terms of their x location. Their y location, or y coordinate location rather, is what's going to change here. How many ever units down something was compared to the x-axis, it would now go the same number of units up, and if something were above the x-axis, it would flip the same number of units down, because that's how you're going to mirror image something. If it's right on the line, it won't move at all. So for instance, looking at point B here, point B is 1 beneath the x-axis. To reflect it, it's got to go 1 the other direction, so 1 above the axis. Point A here, well, point A, as you can see, is 6 units down beneath the x-axis, so now it's got to flip 6 above the x-axis, so that's going to be way up here. Point D is 3 units beneath the x-axis, so now it's going to go 3 above the x-axis and will end up right there. And point C, since it's on the origin, it doesn't really have to go anywhere at all there. And so I connect my points, and notice that my shape is a quadrilateral, so it should still be a quadrilateral when all is said and done. And again, simply just a mirror image of what's already there. And there you go. There's your mirror image created in question number 3. You'll do the same thing in question number 4, but it's flipping across the y-axis, so instead of flipping points this way, you're going to move things this way. to the left and the right. So if it's 1 unit to the right, in the reflection it would be 1 unit to the left. If something was 7 units to the left of the y-axis, when you reflect it, it's going to end up 7 units to the right of the y-axis.